Have you ever heard of an earthquake supercycle? It's one of the biggest mysteries in geology. Imagine a region that stays quiet for centuries, maybe 500 years or even longer, with hardly any seismic activity. Then, seemingly out of nowhere, it gets hit by a series of massive earthquakes, one after another, over a few decades. This long period of silence followed by intense activity is what scientists call a supercycle. But what causes them? That's the million-dollar question. We know that earthquakes happen when tectonic plates, these giant slabs of Earth's crust, get stuck and then suddenly slip, releasing enormous amounts of energy. But why would a fault line build up stress for so long without any release, only to unleash it all in a powerful burst? One idea is that it's not just one single fault line at play. It could be a complex network of interconnected faults. Maybe the stress shifts and gets distributed across different faults over time. So, one fault might be locked and silent, while another one nearby is accumulating even more pressure. When one finally goes, it could trigger a chain reaction, like a row of dominoes falling, leading to that cluster of major quakes. Another theory involves something called slow slip events. These are movements along a fault line that are so slow and gradual, they don't produce any noticeable shaking. They happen over weeks or months and release stress silently. It's possible that these slow slips change the pressure on different parts of the fault system, setting the stage for a future They might be relieving a bit of stress here, but adding a lot more over there, priming the system for a catastrophic failure. This unpredictability is exactly why forecasting earthquakes is still considered impossible. We can identify high-risk zones and say that a major earthquake is likely in the next 100 years, which is a huge window of time. But telling you, it will happen next Tuesday at 2 p.m., we're just not there yet. We can monitor ground movement, seismic waves, and even changes in groundwater. But there's no single, reliable signal that screams a big one is about to hit. Understanding supercycles is crucial for improving our long-term hazard assessments. If we can figure out the mechanics behind them, we can better prepare cities that might be in the middle of a long, deceptive, quiet period. For now, the Earth keeps its secrets, reminding us of the incredible power simmering just beneath our feet. Thanks for watching.